Okay, so I'm sure that you've already did your part in studying algorithms. So you can just use this short discussion as a review. Okay, so an algorithm, or Rodin defined an algorithm as the fundamental concept in computer programming that refers to a finite set of precise instructions in performing a computation or for solving a problem. So it comes from the word algorithm, from the name Al-Khwarizmi, who is a 9th century mathematician known for his work on in Hindu numerals. So he is known uh, for providing a step-by-step process in his solutions. So the word refers to the rules of performing arithmetic using decimal notation. Okay, so now there are a lot of ways to construct an algorithm. Two of the most popular ways are the flowchart and the pseudocode. So I know that you've already learned about flowcharts in CMSC 10. So for CMSC 56, we focused on constructing pseudocodes. Okay, so just a quick review. A flowchart is a diagram or a graphical representation of an algorithm. It shows the sequence of steps or actions that are needed to be performed to achieve a desired result. A pseudocode, on the other hand, is a method of describing an algorithm using a combination of natural English language and computer programming or symbols. A pseudocode is easily understandable and translatable to an actual code using any programming language. So let me emphasize on any programming language. So this means that your pseudocode is not should not be language dependent. Okay, so your pseudocode should not be written in C, Java, or any specific language. Okay, so anyone should be able to understand your pseudocode. Okay, so there are no fixed set of rules in constructing pseudocodes. But as general practice in class, so we follow the following. So when we use when we need arithmetic operations, we will use standard symbols. So we use the plus sign for addition, we use the minus sign for subtraction. For multiplication, we can do the asterisk. We can also do the C dot, or we can simply put two variables together to mean A times B, or we can also use the parentheses. For division, we can use the slash or the division symbol. Okay, so we so for uniformity, we will use a template in writing pseudocodes in class. Okay, so we have the word algorithm to refer that we are constructing algorithms. Then we have output equals algorithm, and then the input. Now the next line after the header is the description of the algorithm. So the description is like a short and concise description that tells the reader what the algorithm is expected to do. And then next to that would be the input. You have to indicate what the input is, what type it is, okay? So for example, if the input is an integer, then you can say input x is an integer x greater than or equal to 0. So it has to be well defined. So similarly, the third one is the output. So the output also needs to be well defined. Then to mark the start of the algorithm, let's put the word start or the term start and then input the body of the algorithm. And then to mark the end of the algorithm, you have also to put the keyword end. So the start and end are necessary for me to know, or for the reader to know, that you're done, or that the pseudocode that you've submitted or presented is complete. So we would not be second guessing whether you were just not able to complete it. Okay, and also it is important to use indentation. Okay, so it is a good practice to use indentation and to also to put comments for easy debugging or checking of your work. Okay. Now, so additional notes for us to be able to understand clearly what you are trying to present. If you're using an if then else statement, it should end with an end if. So why it is important? So that if you miss alignment, we would know where the if statement ends. Okay, so the same for loop, it should end with end for, and the while loop should end with end while. And then, since this is not language dependent, so our list will always start with index 1. Okay, so we will use counting numbers to indicate indices. Strings will also be encoded between quotations. Okay, now algorithms, a good algorithm must satisfy the 7 basic properties, that is input, output, correctness, finiteness, effectiveness, generality, and definiteness. Okay, what does input mean? It means that the algorithm must have an information about what it is reading from the user. Okay, so and then that input, so that's called the input, and that input must come from a specified set, or basically it must be well defined. So the same condition the same condition is expected to be satisfied by the output. So the output, or so your algorithm must have the information, or the your output is the data that goes out of the algorithm, or it is the value that is given out by the algorithm from a given input value. Again, it must come from a specified set, and the output is also known as the solution. Okay, so the output and the input must be well defined. Okay, so an algorithm must display correctness, meaning the output must be correct and it must be produced from each set of input values. The algorithm must also be finite, meaning the output should be produced for a finite number of steps for each input, meaning your algorithm must not have an infinite loop. Okay, so it must learn to terminate and to give out an output. An algorithm is effective, or it displays effectiveness, if individual steps in the algorithm are doable. It means that each step must be implemented correctly and in a finite number of steps. Now, the algorithm must exhibit generality. It means that it will not only consider specific instances, like specific values for input. It must be able to work for several kinds of possible inputs or problems of similar form. So when you say that the input is a list of integers x, then it must work for all list of integers. It must not just work for, let's say, a list with elements all zeros. Okay, and finally, for definiteness, your algorithm, or the steps in your algorithm, must be defined precisely or not ambiguous. Okay, so let's consider the example, this algorithm, the getMax algorithm. So if you notice, there is a description that says that getMax, or the algorithm, identifies the largest integer in the list x. So it indicates the input x, which is a list of integers. And then the output, which is max, is also indicated, which means that the algorithm is expected to give out the largest value in the list. Okay, so now the body of the algorithm starts with start and ends with an end. And you notice that for for there is an end for, and for if there is an end if. Okay, so for property 1, the input, the algorithm, we've seen that the algorithm indicated the input correctly, so it was well defined and it was specified, and the set where it comes from is specified, which is it comes from the set of integers. The output, on the other hand, and also the output is also well defined. Okay, so it's set that the output is the largest integer from the list. Okay, for correctness, so if you trace the algorithm, you would know that um, it will properly define the output. Now, you will learn tracing in the next presentation. Okay, finiteness means again that the output should be produced from a finite number of steps. So this algorithm involves a for loop that runs from 2 to n, or 2 until the length of the list, which, okay, now since the list is finite, then we are guaranteed that the algorithm will terminate because it will end once your after I is equal to n. So therefore it is finite. The algorithm is effective because if you look at the algorithm, the first two lines simply initialize the values of n and max. Both data are derived from the input. Now the body of the for loop checks max. If max is less than I, still this data comes from the input, and it updates max if with x of I if the value is less than x of I. Still, this data comes from the input. So each step in the algorithm are doable, and they're from the input or dependent from the input, so this algorithm is effective. For generality, we know that the algorithm can take in any value, any list of integers x, and if you look at how it is implemented, it does not assume a specific x, so it exhibits generality. And finally, the seventh property, definiteness. If you notice, the steps in the algorithm are clear and are relevant in the search for the largest element. So there is no step that is useless or unclear about its contribution in the process. Therefore, it is definiteness, and therefore the algorithm satisfies the 7 basic properties of a good algorithm. Okay, so now proceed to the next presentation for tracing algorithms.